I want to talk to you about some special patterns that you'll run across when working with polynomials, and if you can identify them when working with these polynomials, then you'll make a lot of your computations a lot simpler and less steps will be involved. I'm going to point out one that you already know that we've talked about from previous chapters. You know that if you have two binomials that look the same except the signs are different, so here we have x plus 4 and then x minus 4, you can rewrite that as your variable, which in our case is x, squared, minus whatever this number is, in our case is 4, squared. So this can be written as x squared minus 16, and that is the same as x plus 4, x minus 4. You know that from our section about quadratics. There are some other little tricks that we have not discussed yet. Let's talk about if you have the square of a binomial. So if we had y plus 3, all of that squared, you know that that equals y plus 3, and you could FOIL that out and get an answer. Well, there's actually a little shortcut where you don't have to write it out like that. The shortcut is you're going to square your first term, so we have y squared. Then you're going to multiply these two, so you're going to multiply y times 3 and double it. So multiply times 2. So y times 3 is just 3y, times 2 is then 6y. And the last step is square your last term. So 3 squared, which is 9. And that's the shortcut. I'll do one more. Look at this one, it's a little bit more complicated. So first step, take this first term, 3z squared, and square it. So we have 3 squared, which is 9, z squared squared, remember when we have a power to a power, multiply your exponents, so we're going to have z to the 4th. Then take your two terms in the binomial, so you're going to take negative 5 times your 3z squared, so that gives us negative 15 z squared, and double it, so multiply times 2, so that gives us 30. So we'll have minus 30 z squared. And your last step is to square this last term. So you have 5 squared, which is 25. And that's your answer. The last pattern I'm going to show you is not the square of the binomial, but a cube of a binomial. So now instead of a squared, we're cubing a binomial. And this is just a general case, so you can see the rule written out. If you have a binomial cubed, what you're going to do is cube your first term, we get a cubed, and also cube your last term, that's where they get b cubed. And in the middle here, you're going to do 3 times a squared times b, and also add 3 times a times b squared. And you can see in this specific example here, that's what we do. We cube the first term, that went there. We also cube the last term, 2 to the 3rd is 8. And in the middle, we did 3 times a squared times 2, and that gives us 6x squared. And this term was then 3 times our x times b squared, which was 4, which gives us 12x. So those are the 3 little shortcuts, and if you memorize these, it might be a lot easier than instead of writing x plus 2 times x plus 2 times x plus 2 and multiplying all that out. Instead, you can just use this nice little simple shortcut.